So now, while we are here still explaining the hydrolysis, okay, here I was actually explaining what the salt on how the salt behaves. So now we're gonna take this salt now, right? Like I said, um, we're gonna take this salt, right? And in this salt, what you're gonna do with it is here is the salt. So you need to understand that this salt, it is from what type of base and what type of acid by looking at this. We're gonna work it out. Now, that's why you need to know your acids and your bases. That table that I showed you, you need to know it. Now, let's follow the steps on how to work this hydrolysis reaction. In exam, they just give you the salt and they ask you to determine if this salt is acidic or if this salt is from a strong acid. Is this salt from a strong acid? Is this salt from a strong weak acid? Is this salt from a strong base? Is this salt from a weak base? You need to know all of those things. What you're gonna do is, first thing that you're gonna do, if they give you a salt like this, you're gonna have to split the salt into ions. So you can see you have NH4Cl. So we have NH4 plus ions, then we have Cl minus ions. And after you split, you're going to identify the acid and the base that form the salt. So look, this is NH4. Obvious. This NH4, it is from NH3. This is HCl, is from H. This is Cl, therefore it is from HCl. So by identifying, you can also do your chemical reaction like so, where you have NaHCl and HCl. That's how we manage to form this salt. You know that it is a base. Ammonia, it is a base. HCl, it is acid. So this guy will donate a proton. Then when he donates the proton, he's going to left as Cl minus. And then this guy, when he accepts the proton, he's going to be NH4 plus ion. And then you can see that these ions, this is positively charged, this is negatively charged. They attract each other. They form NHCl, NH4Cl, right? So that's how you can identify the acid, the base, and the acid for this salt. Now, by looking at this base, you should know, like I said, we looked at the table. We know how does a strong acid look like? How does a weak acid look like? How does a strong base look like? How does the weak base look like? So NH4, which is ammonia, it is a weak base. HCl, it is a strong acid. And we saw that strong acid, strong base, they do not undergo hydrolysis. A weak base, it is the one that's undergo the hydrolysis because it's weak. So we classify the acid and the base in terms of the strength, whether it is a strong or a weak. Here it is. Then this point, the ion of a weak species, you're going to determine the ion of a weak species, this is the ion of a weak species, this is the ion of a strong species. So the ion of the weak base, it is the one that's going to undergo hydrolysis. So meaning, if you take this salt, NH4Cl, and then we want this to undergo hydrolysis to react with water. So the only thing that's going to react with water over here, it is what? It is an Cl minus, it won't. So that means NH4 plus ion, it is the one that is actually going to react with water. And then Cl minus ion, it won't. The only guys that are going to interact with one another is this. You know why? Because this guy, he is from weak base. This guy, he is from strong base. So this guy, he won't undergo hydrolysis. This guy, he won't react with water. Only this guy, he will be reacting with water because he is from weak base. And then you can see that if this is a weak base, if it is from a weak base, if um NH4 plus, he is from a weak base, that will make him what conjugate? He will I mean, this will be acid, conjugate acid. That means this guy will be acid. That's the basic that we spoke about. You can't ask me why. Don't do that, Lina. So that means NH4 plus ion is an acid. And then the water will be base. Then another reaction will take place. You see? So that is why NH4 plus ion, when he reacts with water, um, this guy will definitely react with water. And then he will, remember I said to you, he is an acid, right? So that means he will have to donate the proton, right, to form NH3. And the water will accept the proton to be H3O plus ion. So basically, we're now doing these things in circles. So how do they ask this question in exam? You know how they ask it? You know how they can ask it in different ways. They give you the salt. They will ask you, is this salt from what um class of acid and base? They can ask you like that. Or they can give you this salt and say, perform hydrolysis reaction. You see there, everything that we did, you're gonna do it, and then they want you to show this chemical reaction. You get my point? So why NH4? It is the one from here. NH4 is the only part that's gonna react because NH4 is the ions from a weak base. So Cl minus ion won't react at all. Why this guy won't react? Because he's from a strong base, so no hydrolysis. And then, yeah, that's how it goes now. Let's have a look at example number 2. Example number 2, we have a salt, which is CH3COO and A. This, break it into ions. We're going to have CH3COO minus and Na plus. This, I said to you, you should know. You should know your bases. You should know your assets. This guy, he is from where? If you remember, we have ethanoic acid or acetic acid, the one for vinegar. So this guy is from acetic acid, is from here, CH3COOH. I showed you the table, don't forget that. And then Na is from sodium hydroxide. So this is a strong base. This is a weak, remember, acetic acid, it is a weak acid. Agree? This is a salt. Salt, we broke it into the ions. We determined, okay, this ion is from what type of acid, this ion is from what type of base. So we have established that NaOH is from strong base. So he won't undergo hydrolysis. So that means Na plus minus ion, he won't undergo hydrolysis. The guy who's going to undergo hydrolysis, it is this guy over here. Why? Why do we say this guy he will be undergoing hydrolysis, these ions? Because they're from weak acid. So this guy is the one that's going to react with water, which is H3COO minus will react with water, will undergo hydrolysis. Then water will donate the electron, and then it will take us to the weak acid that we started with. Okay, so break it into ions. From this acid, from this base, we know that it is a weak acid. So this guy will undergo hydrolysis. Then this guy, he is a strong base. This guy won't undergo hydrolysis. So let's perform hydrolysis. This guy, when he goes hydrolysis, there he is. He will react with water to form these products over here. How did we manage to form this product? Water will donate H plus ion to be OH minus ion. Because obvious, remember this, it is acid. Therefore, this, it will be conjugate base. So if this is a base, he will accept. That's why here he will have to accept the proton from water. Then water is an N for light. Water will behave as an acid. So yeah. So you see how they ask this question. Here's the exercise. They're asking, is the salt acidic or basic? Explain with the aid of a balanced chemical equation. When they say explain with the aid of balance, they mean this. So you're gonna perform that. That's your exercise. And let's jump the solution. That was 3.8, hydrolysis, and the conjugate base pairs and so forth. So now we are heading to 3.9. This is more, this is more or less of the calculation side. Um, see the indicators when we're gonna do the titration and whatnot. And now let's go. pH and the pH scale and the pH calculations. You see, here's the thing. We have what we call pH and we have what we call pOH. For pH, we use hydrogen ions, but for pOH, we use hydroxide ions. But, and then this is what you need to know. pH plus pOH, it will give us what? Neutrality, it will give us 14. I mean the range of the scale. Because remember, when you talk about pH, we are talking about the numbers. When you talk about the pH, we are talking about the numbers that are below 7. So I mean we are talking about 1, 2, 3, 4, 5, less than 7. When we talk about pOH, why isn't it writing here? When you talk about pOH, we are talking about the numbers that are above 7, meaning we're talking about 8, 9, 10, up until 14. So from 1 to 6, and then from above 7, which is 8 to 14, how many digits? When you add them, they will give you 14. And so I'm saying to you, pH plus pOH, it will give us 14, which is acid and base. Okay, awesome. So now we know it ranges from 0 to 14. I know most of people, they think it ranges from 1 to 14. Let's fix that. It ranges from 0 to 14 because there can be pH of 0.2. That means it starts from 0. Okay, let's fix that today. I know sometimes you guys love to say pH ranges from 1. I know that. All right. I'm not gonna do this. This is what you did in grade 4. pH is less than, guys, we know those things. Below 7, acid. Above 7, 7, neutral. And most of the time we associate acid as red, alkaline or basic as these colors, blue, these bright colors. And then neutral, it's 7, it's green. Most of the time we did these things in grade 5. Now, here's the thing. How do you test whether the solution it is acidic or basic or neutral? In lower grades, grade 5, grade 4, you would use your, but again, filter P, litmus paper. You will use your litmus paper. If it turns blue, you know it's basic. If it turns red, you know it is acidic. But now you are in high school, of which you are looking at the liquid indicators. We can even use, but again, red cabbage, the broth of red cabbage. But here, for your curriculum, you're gonna use your methyl orange, you're gonna use your promethymal blue, you're gonna use your phenolphthalein. So these are all indicators that you're gonna make use of, more especially when you perform what you call titration. Okay, acid and base titration. So acid-base indicators, we're going to use these these three guys over here to test the pH of the solution, whether the solution it is acidic, or whether the solution it is basic, or whether the solution is neutral. We're going to use these three guys over here. Now, when you talk about the methyl orange, right? So in this case, methyl orange, we say it is a red in acidic solution and yellow in a basic solution. So if you have a solution and then you add your methyl orange and the solution turns red, that means this solution it is acidic. If you add your methyl orange in a solution and it turns yellow, that means the solution it is basic. Same applies to promethymal blue, and now it's the opposite. You see there yellow because it's acid basic, but if you add your bromothymol blue in a solution and then it turns out that the solution becomes yellow, then the solution it is acidic. Don't confuse yellow for basic for methyl orange and yellow in acidic for bromothymol blue. These are different indicators. Then if the solution it becomes blue, therefore the solution it is basic. And then phenolphthalein, if you add phenolphthalein in acidic solution, it will turn acidic solution into colorless. If the solution doesn't change, like it is colorless, it is clear in color, then um, when you add phenolphthalein or when you have the phenolphthalein inside, you will see when you do titration and it's colorless. That means our but again, solution it is acidic. But if it turns to pink, I will try to do experiment online with you, ne? I'll see if I can get that simulation. I'll show you. And then if it turns pink, then the solution it is basic. What? The phenolphthalein. Okay? Yeah, sharp. I don't know. What hint can I give to you? Remember, this is methyl orange, MO. This is bromothymol blue, and this is phenolphthalein. MO, acid, red, right? Basic, yellow. I don't know. Find a way to remember this thing. Maybe you guys cram too much. And then bromothymol blue, you're gonna say um acid, blue, and what is this? Base. It forms. Oh, you know what you can do? You know what you can do? You can say MOBP, and then you form some sort of a table, and then you know this side it is acid, and this side it is base, right? So, oh, I was supposed to write it there at the top, base. And then for methyl orange, you say it is R. For this one, it is Y. Why are you gonna have it here? You say cross multiply. I'm just giving you a way to remember these things because sometimes you need to know them. And then here you're gonna say when you use bromothymol blue, solution will turn B. So remember, oh, if it is bromothymol blue, base B. So here you have base. Oh, where's base? Here you have base. It's gonna be B for bromothymol blue. You just find a way to remember these things. Sometimes I know you guys forget. And then for phenolphthalein, here you have C for colorless, and then here you have P. So you'll remember, oh, phenolphthalein for base, I have P that side. Yeah. So it's just a way for you to learn these things and to remember these things without you confusing them. Okay. That's the idea that I can come about for you to remember these things. And then now let's, as much as we spoke about the indicators, now I want us to talk about the calculations of pH. Okay. To calculate the P, okay, by the way, there is a formula like this, like I told you, it's close to 40. This formula will help you to do what? To calculate pH. And then there is a formula like this. Negative log. You can have H3O plus ion, or you can have H plus ion. It can be like this. There is a formula like this. This formula, it helps you to calculate pH and the concentration. But this one is only for for pH. This one, it is flexible. It's either you calculate the pH or you calculate the concentration. If they give you concentration, you calculate pH. If they give you pH, you calculate concentration. You get my point? And then let's say you want to calculate pOH, right? If you want to calculate pOH, then you will calculate. I will show you. I will show you through example. A question will give you acid, and they want you to calculate the pH of the acid. If you want to calculate the pHO of the acid, you have to calculate pH of the acid first, and then you use this formula, substitute the pH, you transpose minus pH, then you calculate the pHO of acid. Acid can have pHO, acid can have pH, so it's important. Okay, sharp fine. Let's come here. Remember, I said to you, what does autoionization mean? Water reacting with itself. So when water reacts with water, this equation, it is reversible. We have H3O plus ion and OH minus ion. One of the water here is acid and one of the water here is base. So this type of reaction, we call it an auto ionization of water, right? So we have these ions, we have these ions, and then here we have what we call the expression for the equilibrium constant. You see, we have a reversible reaction. So that means this chemical reaction can reach equilibrium. So when we want to calculate the equilibrium constant, which is called Kw, it is called um, um ionization constant. It is called ionization constant. So this ionization, to calculate, you know almost how to calculate Kc, but this is Kw. You're gonna say concentration of the products divided by the concentration of the reactants. So now if you have a look at this is a product, H3O plus ion, which is this, OH minus ion is a product, and then at the bottom we use the reactants, right? Which is water. But we have two molecules of water. We have one, then that's why we raise it to two. So basically, we can write it like this. H2O, balance the equation, klar. H3O plus OH minus ions. You see? We can go like this. So remember, um, why we write squared over there is because of the coefficient, the stoichiometric coefficient of your substance. Hence why we raise it to the power of 2 over there. So just like Kc calculations, so ionization constant, we can express it like this. So now, for Kw, when the concentration of water is very large, compared to the concentration of the products, in a nutshell, when the concentration of the reactant is very large compared to the concentration of the products, or water is a pure liquid, so that the concentration will be 1 mole per cubic decimeter. It can therefore be omitted from the equilibrium constant. So we write 1. Therefore, our equation becomes this. Then this will be equals to that. So another formula that you can use to calculate the concentration of whatever, we can use this equation over here. By the way, no need for you to prove this. It's not for your curriculum. Just know that this is another equation that you can make use of to calculate at a temperature of 25 degrees Celsius, which correspond with how much Kelvin? 23 plus is how much? 25 plus is 298 Kelvin. So it corresponds with 298. You just add 273.15. Yeah. So anyways, this is another equation that we make use of to calculate the concentration. Okay. So this is just the derivation. How was this formula formed? This formula was formed from here and the ideas that we see over here. So for neutral solution, concentration of this is equals to concentration of that, and both of them, it is half to the power of -7. Can you see that? It's half, but there's 14. Half of 14 is 7. Okay. So for acidic solution, it makes sense. We know that the concentration of hydronium or oxonium ions will be greater than that. But for base, the concentration of hydronium or oxonium will be less than that. Something that we know. Let me see here if there is something important. There's nothing interesting here. So now, let's have a look at this. Use the expression to calculate the unknown value. Shame. Where is the unknown value? To calculate this, how to calculate OH minus ion for number 2? You are given H3 plus ion. So what you're going to do is, you are given H3 plus ion. You are not given OH minus ion. So then what are you now going to do? Concentration of H3O plus ion multiply by concentration of OH minus ion is equals to 1 times 10 to the power of -14. We are looking for this, which is here. It's easy. You are given OH, right? You are looking for, you are given 1 times 10 to the power of -2. We are looking for, in exam, they won't even ask you such, man. This is just for understanding. 1 times 10 to the power of negative 14. Then you divide both sides, right? When you divide both sides, you're going to get this value, okay? Then you will do the same for the rest. They won't ask you such things. But even if they ask you such thing, this thing is too easy, right? I believe you guys will get it. And then here's Mandaba. Here's my news. I said to you for pH calculation, you use this formula, your log, right? Logarithmic. And then you're expected to calculate pH of a strong acid or a strong base. You get my point. Okay. Here's another thing. I think it's here. Let me check if it is here. Yeah, here is it. You know what I've realized now? A lot of learners, they always think pH is only for acid because you use these ions for acid. Base does also have pH. You know, people think pH is only for acid. POH, it's only for base. No, acid has POH. Base has POH. Do you get it? Acid is the thing. Acid, it has pH. Base, it also has pH. Get it right and get it right. Okay? Don't think pH is only associated with acid. That's why here, we are looking at the steps to follow calculating pH of an acid. So let's see how are we going to do it. So they say calculate the pH of, this is an acid, right? You are given the concentration of that acid, right? You are given the concentration of the acid. So now let's be step by step. And now here's the chemical reaction of HNO3. You're gonna make sure that you react it with water, and then it is a reversible reaction like so. HO3 plus ions plus NO3 minus ions. Ne? Make sure that you do your equation, even though they gave you one, make sure that you do your equation so that you can balance your equation, so that your equation, it becomes balanced. That's very important. So according to this chemical reaction, we can see that everything is balanced. Hydrogen, we have 1, 3. This side, we have 3 hydrogens. We have 3, 4 oxygens. We have 1, 3. We have 4 oxygens. Nitrogen, we have only 1. And that side, we have only, so meaning this equation, it is balanced. So sharp fine. What are you calculating? You are calculating the pH of this guy. Now, this guy, we have 1 stoichiometric coefficient. And then you focus on, because I said to you, the formula that you're going to use, it has H3O plus ion. So you focus on the guy coefficient, you focus on the H3 minus H3O plus ions again, which is this guy over here. So we're going to perform stoichiometric calculations. Let me write it here. We have 1 mole of HNO3 is to 1 mole. Where did I get these moles? The coefficients of H3O plus ions. So instead, you are given the concentration of this guy. They said it is how much? You have concentration of that guy is going to be 0.2. And then the concentration of here, it is what we are looking for. We don't have concentration of this guy. It's what we are looking for. And then we cross multiply. So you're going to say 1 multiplied by this guy is going to be that guy, which is H3O plus ion. And then you're going to say 1 multiplied by 0.2 is going to be 0.2. Hence why we say the concentration is equals to that. And then because we are looking for pH, then now we can use that equation. pH is equals to negative log of concentration of H3O plus ions. Then you substitute the concentration, you get your pH. This is very important to balance your chemical equation. Hear me out. It's important to balance your chemical equation because the ratio is 1:1. So sometimes it could be 1:2, of which now is going to affect the pH. Now let's come here. Now we have, they say calculate the pH of, and then its concentration is there. So we're going to H2SO4 plus water, you react it with water. And then you know this base and it's gonna donate twice. It's a dibotic acid. Then it's gonna look like this when it donates twice. To make sure that you eliminate H2, all of it, you are left with SO4, 2 minus, because you have donated 2 protons. And then they will come here. But now here it will be H3O plus ion. So there's the chemical equation. And then remember, I said to you, here is our focus, and here is our focus. The stoichiometric coefficient here is 1, the stoichiometric coefficient there is 2. So now the ratio is going to be 1:2. Then 1 mole of H2SO4 is to 2 moles of H3O plus ions. What is the concentration for this guy? We have, it was given to be 0.25, and in this guy, we don't know the concentration. It is what we are looking for. Then we cross multiply. You're going to say 1 multiplied by that guy. It is that guy. Okay, plus. And then we're going to say 0.25 multiplied by 2. That will give us 0.5. And then from here, then we can calculate pH using negative log. You put your 0.5 over here, and then you get your answer over there. So you see why it is important to write your chemical equation and balance it. It's very important. So to calculate the pH of a base, hear me out, pH of the base. That's what I'm saying, Babo. Here, when you calculate the pH, I want that formula. Where is it? This formula. Let me take it from here. This formula. This formula, it is straightforward. Right? And Babo, you use H3O plus, which is ions for acid. Sharp. Let's go to base. So calculate the pH of a base. Okay. Chemical reaction. Right? No need to write water, is dissociation. So that you can see you have OH minus ions. You don't have H3 plus ions because this is a base. You get it. So that's why you don't have to write water there. And then they gave you the concentration of NaOH, which is 0.4. So in this case, you're going to determine the concentration of OH. So you can do it in 2 different ways, by the way. I'll do it on other way around, not in this way. Anyways, from here, we know that, like that formula that I told you, it was derived. This is the formula. Ne? You're going to calculate OH using your chemical balance equation. Using your chemical balance equation, that will enable you to calculate OH. And then after calculating the OH, you're going to substitute it over there, and then you're going to get HO3 plus ion, which is this number over here. Then now you can calculate the pH of the base. That's why it's 13. Because remember, base can have pH as well, not only acid. Even though this equation, it uses a concentration of acid, but we want for base, then it's 13. So if you don't want to do it in this way, you can use that formula that says pH plus POH is equals to 14. You can also do it instead of you using this, you can use that. So what you can do now, you can calculate the pH. You're going to say pH is equals to negative log what am I looking for? You can say pH is equals to negative log, and then you put your 0.4 over here. Sorry, POH, you calculate pH, not pH, because you're looking for base. You're going to say negative log 0.4. You can say more you calculate POH, which is the same as negative log, you put OH minus ion, ne? Then you say negative log, what is OH minus ion? It's 0.4. What is the answer? Let me do it. Negative log 0.4. This is POH. And then I get 0.397, 97 what? 9. Wara wara. Waka waka. This is pOH. And for me to calculate the pH, I'm going to use this. I'm going to say pH is equals to 14 minus pOH. And then I'm going to say 14 minus my answer on my calculator, which is this number. And then let me see how much do I get. 14. I get 13. I get 13.600205999. Is this the same as this one? Yes, it is the same as that one. So there are two ways on how you can calculate it. Ne? So yeah, you can do it in this way or you can do it in that way. It's up to you. Same applies to here. Make sure that the aim is to balance your chemical equation. Ne? And yeah. Let me see here. Yes, calculate the concentration of acid. Now, how to calculate the concentration of acid now? You see, we were calculating pH, but now we need to know how to calculate the concentration using the same equation, where we're going to use the antilog. Here's the thing. Let's say they give you a pH like here is equals to 4,5, and they want you to calculate the concentration. You're still going to use the same formula. You're going to say your pH is equals to negative log H3O plus. Then the pH is 4.5. We are looking for the concentration. You know what you're going to do? What you're going to do is to do your antilog. See this thing? Concentration of HO plus. It will be equals to 10 to the power of negative 4.5. This is the only thing that you're going to do. For you to calculate this concentration, you'll make it the subject of the formula. For antilog, you will say 10 to the power of negative, this number that you see over this side, and then you will get this answer. Now, in mole per cubic decimeter, because you are calculating for concentration, and therefore that will be your answer. And by the way, we are calculating concentration of what? We are calculating concentration of HCl, but making use of this equation, when are you going to get the concentration of what? Of H3O plus ion, which is this. And then remember, we have one, therefore the concentration of HCl will be the same as that one, because ratio this one is to 1. And then here it is for base. We still do the same thing. They gave you the pH. Again, be careful. You have pH for base. What are you going to do? If you have pH, you're going to get this. Okay, let me do it here. If you have pH for base, you're going to make use of this equation. You substitute your pH, which is 11.2. You calculate the concentration. But this concentration, it is for hydronium ions. And then, because we are talking about the base, you have to calculate OH. Then here's your OH, not H3O plus ion. Here is your OH. And then from this balanced chemical equation, we can see the ratio, it is 1:2, which is this. Then you divide by 2 or you multiply by half. Now you can get your concentration of CaOH in this format, because you calculated OH, concentration of OH, which is this one, and then 1/2 multiplied by that, and then here is the pH of CaOH. And let me see. Yeah, then this is for another day. It's going to be long. And yeah, any questions if we do have them?